afternoon, everybody. How are you today? Today's Monday, October 31st, and this is your bell ringer for today. Use synthetic division. What is the remainder? So remember, when we're using synthetic division, we have to have a certain kind of setup. So let's start with this. We're going to put something here in this corner. Then we're going to put some numbers here, and we're gonna do a little bit of math there. So what goes where? Well, the first step is we're going to use the divisor to figure out what goes in that corner. In order to go put that corner, we're going to take this divisor, and whatever the operation is here, we're going to do the opposite. So if it's positive, it's going to be negative. If it's negative, it's going to be positive. So in this case, positive 3, we're going to change that to a negative 3 and put it right over here in this corner box. The next thing we're going to do is we're going to grab these coefficients, the 3, the positive 3, and the negative 6, and we're going to bring them down and write them right over here in this box. So we're going to write 3, 3, and negative 6. Okay, great. The next thing we're going to do is, remember, we draw our line, and then we're going to bring the first coefficient down. This is just the rule that we need to follow. It's the rules that we need to follow in order to use synthetic division. So that 3 comes down, and in order to get the next thing that goes right here, we're going to multiply this times this. So 3 times negative 3 is negative 9. And now we're going to add these together to get what goes down here. What's going on? So let's say 3 minus 9, that's going to be negative 6. Okay, what's the next thing? I want to figure out, the next thing I need to figure out is what goes up here. So in order to get that, I'm going to multiply this times this corner. Negative 6 times negative 3 is negative 18. Positive 18, I'm sorry. Two negatives, multiply a negative times a negative, that's a positive. And that's going to be negative 6 plus 8, or the easier way to look at it is I'm going to look at 18 minus 6, and that's just going to be 12. So how do I know which was which? How do I know which ones are my x term, my constants, my remainders? What if there's an x squared? I don't know. How do I figure that out? Well, here's what I know for sure. Let me make this larger. This last, let's call it this first column on the very far right is always going to be the remainders. The second column to the left is always going to represent the constants. And then the third column is always your variable to the power of 1. If there were more columns here to the left, we would also keep going, and we would have like the x squared or x to the power of 2, then the x to the power of 3, and so forth and so forth. The other way to look at it is algebraically. If I have x to the power of 2 divided by x, which is this, x to the power of 2 divided by x, I know that I use the quotient rule. My result is going to be x to the power of 2 minus this power of 1 that's here in the denominator, which results in x. 2 minus 1 is 1. So that means if I start with this degree polynomial, my answer is going to be 1 degree less. That's just the rule. It's always like that. When you're dividing polynomials, whatever the degree that you start off with, your answer is going to start with 1 less as the first term. So we can look at it again and say, okay, my first term is going to be 1 degree less than what I started with. So this has to be an x minus 6. So then this has to be a constant, and this has to be my remainder right here. So recall, we cannot simply write the remainder as a number, because that doesn't work. When we're writing the remainder, we write it like the remainder divided by the whole divisor. Okay, the whole divisor, everything together, x plus 3, it can't just be the number, it's got to be the whole divisor. So our remainder is going to be 12 over x plus 3. Okay, that's what I was asking for. Use synthetic division. What is the remainder? There's one problem exactly like this on the 4-week exam, so make sure you understand how to get that remainder and how we write it in the correct format. If I were to ask you, find the quotient of this division problem, this is basically the answer down here. You've got your 3x minus 6, which is the constant, and the only thing I need to add is this 12 over x plus 3. And what's in front of this 12? Is that a positive or a negative? That's a positive, so it's just going to be plus. So our final answer is that 3x minus 6 plus 12 over x plus 3. Okay. If you do not understand these steps for this synthetic division, or how to find the remainders, or how to identify the terms, you need to set some time aside, and please come to see me during tutoring hours. I'll be available on Wednesday morning from 8 to 8:40, Wednesday afternoon from 4 to 5, or Thursday from 4 to 5 as well. If you need another time, please come see me after class and we can see what other times I might be available to help you during tutoring hours. So now we're going to start on polynomial zeros. This is a very important concept. I have mentioned this at least a dozen times. We've talked about this over and over and over again, and I've told you this like many times. But before we get to the definitions, let's think about these big ideas. We have two big ideas here. The first one is we can use factors to find the zeros. So in other words, if you know the factors of a polynomial, it's very easy to find the zeros. And our second big idea is we're kind of going in the other direction, and we're saying we can use the zeros to find the factors. So if I give you guys the zeros and you understand what that means, then you can go back, kind of back out and find the factors. So what are the zeros? This is the thing I've told you guys about at least once or twice a week since I started working with you guys during the first semester. A zero is a solution or root of the equation. Okay. We also call them x-intercepts. The x-intercepts, the zeros are called x-intercepts because the coordinates are always x comma 0. Or in other words, y is always 0 because we're right on the x-axis. So let me show you an example. Let's say I have a graph here. This is your, oh my gosh. This is your x, this is your y. And let's say I've graphed this parabola. I have a quadratic function I've graphed here in the blue. And right here where we cross the x-axis, these 2 points, those are the x-intercepts. They also represent the solution to the equation that makes up the graph. We also call them the roots. Okay. In math, we love to use different words for the same thing. It's just something that we do depending on what topic we're talking about. It's easier to make a reference to a particular type of word. But at the end of the day, the most important thing that you need to take away from all of this is that the solution, the roots, the zeros, and the x-intercepts are all the same thing. It's where a graph intersects the x-axis. It's the points on the x-intercepts. It's the zeros, or it's the roots to the equation. Okay. Now tomorrow we'll go over some examples and see exactly what that looks like when we talk about setting the factors equal to 0 and actually solving them. Okay. And that's all for today. Thank you guys. Okay, stop sharing.